In the second part to lesson 5.1, we'll review what it is to find the domain and range of a function from a graph, while also reviewing what domain and range are. And then we'll move on to trying to find the range of a function when the function is written as an equation. If you remember, functions can be written in multiple ways, and one of the most common ways that we write and see functions are as equations, like this one here, y equals 2x minus 3, where x represents the domain or the input values, the numbers that are going into the function, and y is representing the range or the output values, what we're getting out of it after it does its function, in this case 2x minus 3. So we'll be looking at how do we understand what the domain and range is of this type of function, and then how do we find the range when given certain domain values. If you remember from the first part of this lesson, we looked at a graph that had points on it, coordinate points on it, and we identified those coordinate points, like in this case 1, 3, 2, 1, 3, negative 1, and so on, and identified that the domain was all of the x values and the range was all of the y values. Well, it's the same way if the function is written as an equation or as a graph. We just have to identify, okay, how are we going to work out this function and how are we going to find those values, those domain and range values. So in this lesson, we'll be looking at something like this, where we're given some x values, some domain values here, and we're given a function like this, y equals 2x plus 1, and we want to find the range values, the y values. And we'll do that by plugging in the domain values into our function. Okay, you can see that's what's happening here. And then after it gets evaluated, doing order of operations and the simple arithmetic skills that we've already studied before, we get out these y values. And that altogether is our range. And so that's what we'll be doing in this lesson, is plugging in these domain values in order to find our range values. So let's look at an example from our notes where we're given domain values and we're given a function written as an equation, in this case y equals 6x plus 2, and we want to find the y values or the range of this function. Okay, what are all the outputs based off of the domain that's given to us? So to do that, we're first going to set up a table of sorts, an XY table, but with a little bit different than a normal XY table because we're going to have the function in the middle that's going to work on our domain values. So I'm going to put my x's over here. That doesn't need to be a very big column because it's just the values. And then my function is going to go here, right in the middle. And then on the other side, it's going to be my y values, or my range. And that's what's going to get shot out of the function, okay, or produced out of that function. So first I can see my domain values here, negative 1, 0, 1, and 2. So I'm going to go ahead and put them here, negative 1, 0, 1, and 2. And I'm going to take each of those individually and plug them into my function. Okay. And when we say plug it into the function, it's like what we've done in the past. These are my x values. So this negative 1 is going to get plugged in for x. I'm going to take out the x and put in the negative 1. Okay. And remember, when you have a number and a variable together like that, that means multiplication. So when I put in that negative 1, I'm going to be multiplying it with this 6. So this is what it would look like. Y is equal to 6 times negative 1 plus 2. Notice I took out the x and I put in the negative 1, and it's going to be multiplied with that 6. So then to simplify, 6 times negative 1 is negative 6 plus 2, and negative 6 plus 2 is negative 4. And so that's my first range value. So I put in a negative 1 into my function, and it shot out a negative 4. And so that's the range. And so I can go put that over here, negative 4. Right? That's the range value that goes with the domain of negative 1. All right, so let's keep going. I'm going to plug in 0. Y is equal to 6 times 0 plus 2. 6 times 0 is 0 plus 2 is equal to 2. So when I plug in 0, I get 2. Plug in 1, y is equal to 6 times 1 plus 2. 6 times 1 is 6, plus 2 is equal to 8. So 8. And then lastly, plug in 2. Y is equal to 6 times 2 plus 2 is equal to 6 times 2 is 12, plus 2 is 14. So I have here 14. So in order to find the range of this function, 6x, y equals 6x plus 2, I took each of the domains that they gave me in the problem and plugged them into the function and evaluated, and that gives me my range. And so when we're finding the range of a function, when we're given the equation, we can just plug them into the equation and see what we get, and that will be our range. And notice again that in my xy table here, I am matching up the domain and the range. Okay? Matching up the domain and range. If we were just writing out the domain, we wouldn't necessarily have to match them up, but because we're putting them in an xy table, we want to make sure that our points are matched up. All right, let's look at one more example, also in your notes. Y equals 1.5x plus 3. So this is our function, okay, and this is the domain that's given to us, -1, 0, 1, and 2. And we want to figure out what's our range from this domain. So I'm going to do this the exact same way we just did the previous problem. Okay, I got my xy table, x on one side, my function right here, and my range over here. And then I'm going to put each of my domain values here, and I'm going to plug them into for x. Okay, it's 1.5x plus 3, and so I'm going to plug each of these values in for x. So y is equal to 1.5 times -1 plus 3 is equal to 1.5 times -1 is -1.5 plus 3. -1.5 plus 3 is equal to 1.5. Now don't be frightened by the decimals. Those are numbers like any other. And if you don't feel confident in adding them, -1.5 plus 3, then just use your calculator. You'll find that it's 1.5. Do the same thing for 0. Y is equal to 1.5 times 0 plus 3. 1.5 times 0 is 0 plus 3 is equal to 3. Oh, I guess I didn't put this in over here. You could do it all at the end too if you wanted to. Then I'm going to plug in 1. Y is equal to 1.5 times 1 plus 3 is equal to 1.5 plus 3, which is equal to 4.5. So I put in the domain of 1, and I get out the range of 1.5. Lastly is 2. Y is equal to 1.5 times 2 plus 3. 1.5 times 2 is 3. 3 plus 3 is equal to 6. Again, use your calculator where necessary. And so there's my range, 1.5, 3, 4.5, and 6, based off of the domains that were given to me, the domain values that were given to me. So I took my domain, plugged it into this function, and I get out my range. And that's how you're going to find the range of the functions given some domain values. Again, the main thing you just got to remember is my domains are my x's, they get plugged into my function, and my range are my y's. That's what comes out.